Time. It's a fascinating topic, isn't it? Time dictates us when the flower blossom, when the birds migrate, and even when we feel most productive in the day. Today we're going to deep dive into how profit model works, which was developed by Facebook and which helps us capture this integrate patterns of time. So welcome to this in-depth yet intuitive video where we're going to talk about the inner workings of the profit model. As I mentioned, everything has a pattern and every variable can be exposed in terms of time, right? So in order to understand how profit captures these patterns, we need to understand a concept called seasonality decomposition. This involves breaking down a time series into its main components: trends, seasonality, and residuals. Now let's talk about these concepts in a more relatable way. So trends shows us the overall direction of the data over a long period of time. So imagine if you're tracking the number of ice cream sales within a city over several years. So if you see that the sales are generally increasing over a year, it means that the trend is going upwards. If it's decreasing over the years, it means the trend is moving down. Whereas it can also remain stable over time. There can be complex trends that can be captured, but profit model regularly uses linear or a logistic way of capturing trends. Seasonality captures the patterns that repeat at regular intervals within our data. So using the same ice cream example again, you might notice that sales spike every summer and deep in winter, right? So these repeating patterns that occur every year or every week or either every month are can be termed as seasonality. So let's imagine a scenario where the sales of ice cream is increasing when there's an economic boom and decreasing when there's a recession. So these cycles can last for varying lengths of time and they don't repeat at regular intervals, right? So these are basically seasonalities, but there is a specific term called cyclicity that is a seasonality without a specific frequency. Generally, we separate out the trend seasonality and residuals from the data by two ways. One is additive decomposition and other is multiplicative decomposition. In additive decomposition, we assume that the components add up linearly. In multiplicative decomposition, they multiply. Multiplicative decomposition is generally used when we might probably see the increase in seasonality with respect to increase in the trend. Now that the basics are covered, let's head on towards understanding how the profit model works. I'll explain this by using the same example of the ice cream sales. Although we don't have the real-time data over the years, however, I think the good way to start with would be using Google Trends. I'll search for the term ice cream and it will show me the trend over different years. As we can see here, it seems like the sales is seasonal. Basically during the summer months it seems to have a peak around May and April, and the increase in the search of the term ice cream has been prominent in this data. So I'll download this. Now once it's downloaded, let me explain how the code works. Firstly, I have imported the necessary libraries. So this line of code is used to read the CSV file that we just downloaded, and profit model specifically uses a convention wherein the column name should be either DS or Y whenever we try to feed that into the model, right? So we need to rename that columns if you have any different column names. Once that is done, let's try to do an exploratory data analysis to see what are the fluctuations of the trends within the year. So we specifically see that over the month of April and May, we have a higher peak, right? So it seems during the summertime people are searching for the term ice cream more. Then we need to convert the data into the required format. we see that the data is increasing with respect to time, and even the seasonality is increasing year over year. So we can assume that this model is multiplicative model, as we had already discussed it previously. So when we multiply all of this together, we get the final original value. That's how the multiplicative decomposition works. Now I'll move to the main part where I explain the hyperparameters that are used in the profit model. So basically we have discussed the additive and multiplicative concepts in detail, and the value that we have passed on the seasonality mode is obviously multiplicative. When we look at the seasonality prior scale, this is the value that controls the strength of the seasonal component. It ranges from 0.1 to 10, and the higher value allows more flexibility in the seasonality. So the more value you add, the more seasonality fluctuates. Apart from trends and seasonalities, there might be external variables that we might know of that could impact the fluctuations within our data. So we pass them in the form of holidays in the profit model, and there's a hyperparameter called holidays prior scale that ranges from 0.1 to 10, similar to seasonality prior scale, and it controls the flexibility of these holiday effects. We'll discuss on how this is passed in the model. Then there's something called change point prior scale that ranges from 0.01 to 0.05, and it determines the flexibility of the trend by controlling how much it can change during the change points. As we know, our data might have abrupt changes within the trajectories, right? So profit model is actually able to capture that by using something called a change point. So change points are the points within our trajectory wherein there is actually a change in the rate of the data. So profit by default specifies 25 potential change points, which are uniformly distributed within the first 80% of the time series. There's also a way to change that value by using something called change point rate. If you want to increase that value from 80% to 90%, you just change the value to 0.9 in the change point rate. Instead of using the automatic change point detection, you can also manually specify the locations of the potential change points by using the change points argument. So you pass in an array of the date time, and that's how it works. Now let's move towards seasonality. So profit models has different ways of determining seasonality. One is yearly seasonality, where if you think every year there is some patterns within the data. Weekly seasonality, if within a particular week there are different patterns, and if you think within a day itself there are different patterns, you use daily seasonality. So it takes a binary value of true and false. However, yearly seasonality might also take a numerical value. So talking about growth, this is something we had discussed in the first part of the video. It can either be linear or logistic, and if we're passing a logistic growth, it should also take in a cap value that is generally 1.5 times multiplied by the maximum value that is present in the data. So finally, let's see how holidays are passed in the profit model. So we create a holiday data frame and pass it into the holidays parameter. This data frame comprises of a holiday name along with the date time of those holidays. It also comprises of a lower window and upper window. So lower window is basically like if you have a Christmas holiday. So if you want to count Christmas Eve into the picture, you want to set the lower window to -1. And for the similar example, if you think Black Friday is a holiday, and if you want to add Thanksgiving to that part, you would want to add +1 to the data. I added these specific dates into the holiday data frame because I saw in the data that over every span of 5 years there was a sudden increase in the search of the term ice cream. We had separated the data into train and test, wherein the train has the data of 10 years and the test has the data of 3 years. So test data frame is used to evaluate the model and the forecast and calculate the MAPE value. So once I pass and feed the model with the trained data, I create a future data frame that is the length of the test data frame of 3 years. And once I predict the future values, I see that the model is actually performing well with a MAPE value of 8. Profit model also allows to plot the components of the model in a graphical format. So we see the trend is linearly increasing year over year. The holidays, as we had passed, there is a sudden spike within a span of every 5 years. And in the yearly seasonality, we can see over the month of April and May, there's a sudden increase in the search of the term ice cream. And that's what the seasonality graph shows. In this video, I've explained the hyperparameters that are used in profit model and how it works internally. If you want to go through the resources that I've used, you might find those in the description below. If you also want to take a look at the code that I've referred to, please find the GitHub link in the description itself.